Hello, good morning, and this is Bhaskar. You're watching Bhaskar 10. Okay, today we're looking for the next concept that is exceptions. So you already studied this one. Again, we are going to revise that one. What is exception? Exception is nothing but just like an interrupt only, but interrupt it is one of the exceptions. Let's see what is the exception. So today in this video, looking for what is the exceptions, what is the numbers of exceptions we are going to use, and what is the sequence of exceptions. Okay, the first, what is the exception? Exception is nothing but just like an interrupt. Interrupt, what it will do? Some process is going on. You have to stop that, go there, and you have to execute that work, another work, and come back and execute the normal work. Similarly, an exception is a condition that need to halt the normal execution of the instructions. If I have a main program consists of many number of instructions. If any one of the condition it is satisfied, then go to the subprogram or sub particular condition, need to execute that one, and after that you'll come back and execute the normal program. So it is halt the normal program condition. It is called your exceptions. So for example, there is given resetting of ARM processor. Resetting of this normal program is running on. Suppose if you are going to reset, suppose if you if you reset my system, so what happen here, it is alter my program, right? It will stop whatever the program it is executed, it will be stopped and go there and it will be executed. This is called exception. Similarly, failure of the fetching instruction. Suppose if you want to fetch any one of the instruction, so we'll see that a hanging mode, something it is happening, right? That time I have to stop the process, right? So this is the cases. It is an example of my exceptions. And so an interrupt is one type of exception. So many exceptions is there. So we'll see that one. So here it is interrupt is nothing but it is one of the exception. Okay. Next it is exception types. Then what are the exception types it is available? Exceptions are numbered into 1 to 15 are for system exception, and 16 and above are called external interrupt inputs. So it's very simple. 1 to 15 are called system exceptions, and more than 15 what we call up to 256 something 255. So we call as an interrupts. Okay, most of the exceptions have programmable priority. Means by giving the program, by using the program, easily we can set the priority of the exceptions. Most of that. Okay, some of are fixed priority, some are not fixed. Means easily by using the program we can give the priority, and it support 1 to 240 interrupt. So totally it support up to 1 to 240 interrupts. Let's see one by one. Okay, now exception types. So see that carefully, you see that this is exception number. We are given 1 2 3 4 5 6 up to 15. More than 15, so what we call as an interrupt. See, exception number 1, it is reset. It is having a highest priority. So see, the value of priority is -3, means if having a negative value, it is having the highest priority. If you have a positive value, it is having the lowest priority. So reset, it is a priority level, it's -3, it's nothing but highest priority. First see the what is the exception type, later we'll see the priority. Okay, so here exception number 1 2 3 what we are going to use is all three are having some priority of -3, -2 and -1. So reset is nothing but reset only. So non-maskable interrupt means when it is come to an existence. Suppose if non-maskable interrupt come to an existence. I give an example of non-maskable. For example, in my class, suppose HOD and lab instructor it is coming. I have a rights to stop my lab instructor, not HOD, right? HOD having highest priority. It is not maskable. I need to allow, right? So that's why here it is non-maskable interrupts having the highest priority. The priority level it is -2. Above that you have a reset. Compared to my reset, NMI having the lowest priority. So compared to NMI, hard faults having the another lowest priority. So hard fault means when you come to an existence, all fault conditions, if corresponding fault handler it is not enabled. For example, one program it is running, some of the instruction is not executed. Sometime it will go for hanging mode conditions. So fault if it is occur, that time this exception it will be arises. Similarly, memory management fault means suppose looking for memory management. while handling the memories, so sharing the memories, that time the error it will be occur. Similarly, bus fault, so communication between, suppose if it is connected to many components in architecture, some any problem is arises in bus, that is also it is one of the exception. Similarly, usage fault, exception, especially usage fault, it is arises during the coprocessor. Okay, while handling the coprocessor, so that time some error arises, that is called usage fault. And 7 to 10 exception numbers we're looking for reserved. And next 11, exception number 11, it is called SV call, is nothing but system service call. Okay, if you want to go for any service, that time it will give the, that is also one of the exception. Similarly, debug monitor, if you debug monitor, debugging components like breakpoint, watch point, or external debugger request, anything it will come, that is also one of the exception. And exception number 13, it is reserved. Okay, similarly, exception number 14, PND-SV, is nothing but pendable request of system devices. Okay, similarly 15 is nothing but system tick timer. So these are all exception types 1 to 15 what we are going to use. See, 1 to 3 means exception number 1 having a priority of -3, 2, -2, 3, it is -1. After that, 4 to 15 all are it is programmable. By using giving the program, easily we can set the priority. If you want, for example, I want to give highest priority usage, but okay, you can give making the value it is 0 or some negative value. So default, see that there is no exception number 0. It's always started by 1. Keep in your mind. Okay, so all the priorities, these are all the exceptions. Then what is the exception number 16 onwards? So that is our case. Okay, so 16 to 255, what we are going to use are all my interrupts. They're all programmable. So by using the program, I can give the priority for that. Okay, 16 to 255, all exceptions are programmable. By giving the program, easily we can set the priority. Okay, so these are the exception. Let's revise again. Exception is nothing but exception is a condition that need to hold the normal execution of the instruction. Example, resetting ARM processor, and interrupt is one of the exception. After that, we studied so 1 to 15 are system exception, 16 above are called interrupt. Okay, it is usually by using the program, easily we can give the priority for that. Okay, 1 to 240 interrupts is available. Next, we discuss about what is the different types of exception 1 to 50, and what is the priority, and what are the exceptions what we are going to use. And more than 50, after 15 16 to 255, it is taken as an interrupt. So all programmable. By giving the program, easily we can set the priority. Now next task it is exception sequence, just like interrupt. So interrupt mechanism, what we did first, interrupt request come to an existence. Second, it is suspend all the task. Third thing, it is execute interrupt service routine. Next, it is fourth one, it is return. Similarly, here also, first different steps is there. First, it is acceptance of exception request, just like interrupt request. Second thing, it is exception entrance sequence. Before going to our execution, some of the process it will be going on in our processor, that is exception entrance sequence. Third one, it is exception handler execution. Fourth one, it is return. So we'll see the exception return. We'll see one by one. The first case, acceptance of exception request. Accept, I need to accept. Suppose one exception, nothing but an interrupt come to an existence from the external peripherals. So my system will not accept that one. If I want to accept, it need to be follow some of the conditions. If all the conditions are satisfied, then only it will be accept my exceptions. So what are the conditions? That's why the processor accept an exception if the following conditions are met. What are the conditions? First condition, the processor is running. If it is there in a shutdown mode, or it is in halt mode or reset state, my system, my exceptions will not accept it. First condition. Second condition, the exception is enabled. Means, so exceptions is enabled. Default non-maskable interrupt and hard fault exceptions are always, it is enabled. Suppose if you want to use any one of the exception, memory management or bus, so it means particular exception should be, it is enabled. Third thing, it is the exception has highest priority than the current priority level. For example, one priority level exception is going on. If I want to accept the highest priority, if I want to accept another exception, means that exception having the highest priority than currently running exception. Okay. Fourth, it is the exception is not blocked by your pre-mask resistor. So it is not blocked by your pre-mask resistor. So four conditions, four conditions need to be satisfied. One, it is processor it is running. Second, it is exception it is enabled. Third one, it is having the highest priority, it is not taken. Okay, the exception should be it is having the highest priority than currently running the priority of exception. Fourth one, it is not blocked. Okay, if all the conditions are satisfied, then my processor it will be accept the exceptions. Next, once it is accepted, not directly it will be executed, but something is happening in my processor. What are the things it will be happen? First condition, first stacking means we studied about when come to I already explained when come to a factorial of a number, your recursive function that time we're looking for one function, just put the all link register value into the stack. Similarly, here also stacking is nothing but push whatever the link register, because after going to execution of my exception, I need to come back, right? So I need to push the return address into my stack. Not only that, it some of the values, register values into the stack. It is called stacking. Stacking is nothing but pushing of number of register, including the return address of the currently selected stack. So everything should be pushed into your stack. Next, if the processor was in thread mode, so two modes is there. So initially, suppose my processor is there in the thread mode using the processor stack pointer, main stack pointer. So in thread mode, it will operate the two stack pointer. We already know that processor PSPR, MSC, processor stack pointer, main stack pointer. Next, fetching the exception vector. So what we are telling it is having a starting address of exception handler at the interrupt service routine. So first I need to get the address of exception. Okay, from the exception vector table. Next it is fetching the instruction. First I need to get the address. Second thing it is I need to fetch the instruction. So after fetching, just update all my stack pointer value, link register value, and program counter. So this is the before execution. Some of the process is going on. What are the processes going on? It's called it is an entrance sequence. First, I need to push all the values to the stack. Second thing, it is processor present. It is in thread mode. It is present in the programs. What type of pointer we're going to stack pointer? Maybe it is a process stack pointer or the main stack pointer. First, I need to get the address. Next, I need to fetch the instruction. So, and also update all my register. This is the second step. Next, what is my third step? Exception handler execution. So, exception come to an existence of how to execute it. It will give a service to my peripheral, right? Within the exception handler, you can carry out a service for the peripheral that requires service, because the request it is coming from our peripheral only, right? It will come to peripheral. So based on the requirement, it will give a service by exception handler. Okay, the process is in handler mode. When so you already know two modes, thread mode and handler mode. Suppose it need to be jump, right? Thread mode to handler mode. If you go there, when exception comes in existence, jump from thread mode to handler mode, give a service there. Okay, the processor is in handler mode. When exception handler in handler mode, the main stack pointer MSP is used for stack operation. The processor is executing in a privileged access level. Okay, in handler mode, the main stack pointer we are going to use and the processor is executing the privileged access level. These are all the things we discussed. Okay, these are all the things we'll discuss in the second module. Just see that, see here. So processor is there in thread mode. So it will equal to privileged access level. When come to exception, come to request, then go to this handler mode. So when present in the handler mode, that's what I'm telling. Handler mode, the main stack pointer we are going to use. Suppose if it is present in the thread mode, we're looking for process stack pointer, main stack pointer, both we are going to use. But suppose if it is jump to my handler mode, we are going to use main stack pointer. And the processor is an executing the privileged access level. Two things, privileged as well as non-privileged. So privileged means secure way. It will be executed if it is present in the handler mode. Okay. So this is a execution of exception handler execution. So okay, next. After execution, if highest priority exception come to an existence. Okay, sir, if execution is takes place, suppose if we come to highest priority as well as lowest priority are same, then how my processor it will be changes, how it is acting, that's very important. If a highest priority exception arises during the stage, the new interrupt will be accepted. So new interrupt will be accepted. First it will be accepted and the currently executing handler will be suspended and preempted by the highest priority handler. This is called nested exception. So nested exception is nothing but if highest priority interrupt come to an exception come to an existence, it need to be stop the process and execute that one, right? This is called nested exception. Okay. Next, suppose if another exception with the same or lowest priority it is arises, then how my processor will working? That's very important first, right? Okay, the newly arrived exception will stay in the pending state. It will not execute that one. So it should be present in the pending state and will be serviced when the current exception handler is completed. So if suddenly two exceptions come to an existence, one it is executing, one it is having lowest priority means should be present at the pending state. After servicing the previous exception, then it will be serviced for this pending state exception. Okay, so highest priority means suddenly it will allow, and lowest priority means it will give a pending state. Okay, this is the exception execution. Next is exception return. Okay, exception service, everything should be over. Then, if it is a return, means return also it is not suddenly it takes place. Something is happening in my processor. What it will happen? First is exception return. At the end of the exception handler, the program could execute a return that caused the exe return value to load into the program counter because program counter having the next executable instruction on the right address on the right. Yes, if my exe return value just loaded to my program counter, then automatically after servicing the exceptions, it will come back and execute the normal program. So and if exe come to an executed, some mechanism will happen, return mechanism. How come to return mechanism? First, initially we stack something, right? Now I need to do unstacking. That's why, see, when the exception return mechanism is triggered, the processor access the previously stacked register. Stacking what we are going to use, push all the values, right? Now we're looking for pop operation. We are getting all the address, all the register values. Okay, when exception return mechanism is triggered, the processor access the previously stacked register values in the stack memory and restore them back to register bank. So restore, and this is called unstacking. It is called unstacking. Okay, not only that, in addition that number of NVIC registers like a PSR and ASP stack pointer, control register, everything should be is updated, will be updated. Next, what is the instructions we are going to use? Instruction that can be used for trigger exception return is EX register, EX register. If the exception return value is still in the link register with the exception, for example, it is there in still, it is not go for any register, it should be present in the LR register only, means just go to BX LR. We are going to use that in order to perform the return instruction, perform the exception return what we are going to use. So this is what we are discussing, the exception. So what we discuss, what is the exception, what are the exception types we discuss. So how many exceptions we are going to use? 1 to 15 normal exception, system exceptions, 55 interrupts. After that exception sequence, first is acceptance. If you go for acceptance of the condition it is satisfied, running, enable and highest priority and not blocked. And after that we discuss about the exception. It will do some pushing operation, stacking operation, a thread mode condition, what is the stack pointer we are going to use, and exception vector table, how do we want to do, how to execute my fetching of instruction. Next it is updating my stack pointer. So after that we'll go for a handler mode, what are stack pointer we are going to use, what type of access level it is there. These are things we discuss. Okay. After that, we discuss about highest priority come to an existence, how my processor it is working. Lowest priority come to an existence, how it is working. After that, what is the return address we are going to use. Okay. So sorry. So and after that, so after exception returns, we are looking return come to an existence. What are the registers we are going to use? So in the next video, looking for exception priority.